worksheet that I gave you since I wasn't much help today because I was packing up my room and stuff for the hurricane. So 1.1 through 1.4, which is really 1.5 mixed practice. So points, lines, and planes. This right here is a plane. It's like flat surface. It's like your desk. So it says determine a point on plane P. So this is how they are labeling it, point P or plane P. Any point that actually falls on the line or on the plane would count for this. The only non-correct answers would be F or G. Those are not points on the plane, or M or L. M and L are the names of the lines. So these are also not points. So you could say point A. You could say point B. You could say D or C. You could also say E. Any of those are correct. So as long as you put that, that is correct. Then it says determine the intersection of line L and M. This kind of looks like a T or a C, but this is a cursive L. So where line L and M intersect at is point B. Identify another name for line M. Line M can be used using the variable next to the line or 2 points on the line. So you could say DB with a line over top, or BD means exactly the same thing. Identify collinear. Collinear means points that fall on the same line with point A. Point A is on line L. So you could say B and C. B and C are both points that are collinear with A. They fall on the same line. Now we're going to get into segment addition postulate. So for these, you're going to want to draw a picture since the picture is not given. So it says if point F is between E and G. I wouldn't even read the rest of this. I would draw a picture of this. So if I draw a picture, F is between E and G. So I'll put E over here and G over here. It tells me EG is 71. So this entire length is 71. EF is equal to 8x minus 17. And FG is 5x minus 3. You need to find the value of x. So they're giving you piece plus piece equals the entire distance, which is 71. So the equation for this would be 8x minus 17 plus 5x minus 3 equals 71. And then I'm going to combine like terms. So if I draw my line, if I combine like terms, I have x's that are on the same left side together. They're both positive. 8 and 5 are both positive. So I'm going to bring down 13x. If I look at 17, which is just a number, and negative 3, they're on the same side. I'm going to combine like terms. Negative 17 plus negative 3 is negative 20. And now I'm going to bring down equals 71. And now I'm going to move the number over to the 71. So the number that's by itself, this is called a constant. It says minus 20, so I'm going to add 20 to both sides. $13x equals 71 plus 20 is 91. And then I'm going to divide by 13 on both sides. So x equals 7. Now I'm going to do number 6. Number 6 is similar. It's still segment addition postulate. This is from 1.2. So you can look back at your notes. This says if Q is the midpoint, so it's in the middle of PR. So I'm going to stop there. I'm not going to read the rest of it because it's going to confuse me. I'm going to draw a picture of just this part. So if I have a segment, Q is the middle or the midpoint of PR. So from P to R, Q is the midpoint. So I know these are congruent segments. They are equal to each other. Determine the value of QR if PQ is 7x minus 16 QR is equal to 4x plus 2. Since they're congruent, I cannot do piece plus piece equals whole. I don't know the length. So I cannot do it the same exact way as this one. I knew it was equal to 71. But in this case, I know that they are congruent. They are equal to one another. So I'm going to put piece equals piece because they are the same. It is a midpoint. So I'm going to do 7x minus 16 equals 4x plus 2. And I'm going to draw my line. And you're going to move whatever you prefer. I'm going to move my number from the left to the right. So I'm going to move my negative 16 to the 2. So the opposite of minus 16, since I'm moving across the equal sign, I have to use opposite operations. I'm going to add 16. When I do that, they cancel. What I do to one side, I must do the other side. Numbers have to go with numbers. They cannot combine with a variable. So I'm going to bring down 7x equals 4x. 2 plus 16 is 18. Now, since I moved my numbers, my constants, I'm going to move the variable to the other side. To move across the equal sign, I'm using opposite operations. It is positive 4, so I'm going to subtract 4 to both sides. Cross them out. 7x minus 4x is 3x equals 18. Last step, divide by 3. So x equals 6. I need to find the value of QR. QR is this segment right here. So now I'm going to substitute my x value back into my equation. So I have 4x plus 2. I'm substituting in my value. So I have 4 multiplied by 6 because I got x is 6 plus 2. 4 times 6 is 24. Adding 2. So QR is actually equal to 26. Okay. Moving to 1.3. 1.3 was all about midpoint. So this is using the midpoint formula. Midpoint formula is x1 plus x2 divided by 2 and y1 plus y2 divided by 2. So that's the formula that we talked about in class. So I'm going to label this x sub 1, y sub 1. It's the first coordinate point. X sub 2, y sub 2. I'm trying to point. So I'm going to take my x values, 3 and negative 2. I'm going to add them together, divide by 2. 3 plus negative 2 is 1. 1 divided by 2 is 0.5. That is the x to my midpoint. I'm going to do the same thing with the y's. I'm going to take 6. I'm going to add 9, divide by 2. 6 plus 9, divide by 2. 6 plus 9 gives me 15. Divide by 2. Not going to go in evenly, but it's 7.5. So you write this as a coordinate point, which is 0.5, comma, 7.5. That is the midpoint between those 2 points. This one's slightly different. It said last time A and B find the midpoint. This is slightly different. It says if C is negative 4, 5, and D is negative 6, negative 2, where D is the midpoint for CE, I need to find E. So E is what I'm looking for. I know that D is in the middle. D is at negative 6, negative 2. And C is in the beginning, which is negative 4, 5. I'm trying to find that other endpoint. So it's slightly different. I'm using the same formula, but now I know what it's equal to. So I'm going to label this x sub 1. This is x sub m. So we're taking this, negative 4. We are adding our other endpoint. We don't know what it is. So I'm just going to call this x, y. So negative 4 plus x divide by 2. I know what it's equal to. I know where I'm at in the middle, which is -6. Now I'm undoing my equation. So I'm going to get rid of that denominator. I'm going to multiply both sides by 2 because the opposite of division is multiplication. Cross them out. -4 plus x equals -12. Now I have a one-step equation. I'm going to move the -4 over by adding 4 to both sides. So x equals -8. I'm going to do the same thing for y. I have this piece. I usually am adding the other end piece, dividing by 2, and that's going to give me the midpoint. I know I have to end up at -2. So I'm going to label this y sub 1. I'm trying to find y. I know this is where I'm ending up, which is y sub m, because it's the midpoint. So I'm taking 5. Do it over here. 5. I'm adding some value y, the other endpoint, divided by 2, because that's my formula. And I know I'm going to end up in the middle, which the middle is -2. So now I'm undoing this. The opposite of division is multiplication. So I'm going to multiply both sides by 2 to get rid of the denominator. Oops. So I'm going to bring down 5 plus y equals -4. Last step, get rid of the +5. It is positive. The opposite of positive is negative. So I'm going to subtract 5 to both sides. So y equals -4 minus 5. It's -9. So the other endpoint that I'm looking for is -8, comma, -9. Okay, on to the back. So that was 1.3 midpoint. Now we're going to do 1.4. 1.4 is weighted average. So your weighted average formula, this is also in your notes. I'll put it up here. For the weighted average, it is taking your first weight and multiplying by your first x value. And then you're adding the second weight multiplied by the second x value, which is where that's at. You're dividing by the weights combined. So I'm going to do weight 1 plus weight 2. Okay. So I'm going to label this. My first point says that find the weighted average of a line segment if point A has a weight of 3. So I know my first x value is at, I should use red. My first x value is at -1. The weight for the first point A is a weight of 3. My second variable is point B, and it has a weight of 2. So the second x is at a location of 6, and this one has a weight of 2. So I'm going to plug in my values. So it's weight multiplied by location plus weight multiplied by location divided by the weights added together. So I'm going to do -1 or 3, sorry, the weight 3 multiplied by -1, weight times location. I'm adding weight times location. So 2 multiplied by 6. And then I'm dividing by the weights added together, which is 3 plus 2. Okay, so I simplify. 3 times -1 is -3. I'm adding 2 times 6, which is 12. I'm dividing by 3 plus 2, which is 5. 3 plus 12, -3 plus 12 is 9. 9 divided by 5 is a decimal. It does not go in evenly. This is equal to 1.8. So 1.8 is right here. That's where my point is. It should be closer to the heavier weight. A was heavier, so my point is pulling towards A. So it always leans towards the heavier weight. The last thing we talked about for this unit was 1.5, which was partitioning a line segment. So this is the last thing. It says, and I guess I should write the formula first. So partitioning is if you're taking your X value, the first X value, I'll put it over here. Yeah, X sub 1, and you're adding the ratio as a fraction multiplied by the difference between your X's. Then you're going to do the same thing with the Y's. You're taking your first Y value, you're adding the ratio as a fraction, and you're multiplying by X sub 2 minus X sub 1. So that's going to create a new quarter point. So it determines the partition point P that is 3/4 of the way along the directed line segment from C to D. So I'm going to call this X sub 1 and Y sub 1 and X sub 2, sub 2. And I'm going to plug in my values. So I'm going to do X's first. So the first X value is 6. I'm adding my ratio as a fraction. Since it gave me a fraction already, 3/4, I can just keep that as 3/4. In parentheses, I'm subtracting the difference. So I'm doing -3, x2, and I'm subtracting x1, which is 6. So I'm doing 6 plus 3/4. -3 minus 6 is -9. Now, when you do this 3 divided by 4, this is where people mess up. 3/4 as a decimal is 0.75. If you're not sure how to get that, you're literally taking 3 and you're dividing by 4. A fraction is fancy division. So 3 divided by 4 gives me 0.75. I'm going to multiply by -9. That gives me -6.75. If you bring down plus -6.75, so adding a negative is the same thing as subtracting. So I'm going to do this. 6 minus 6.75 is -0.75. So the reason why you're multiplying by 3/4 is because this represents the entire length that it's running across on a graph. You're going 3/4 of that distance. So you're technically running a total of 9 to go from -6 to -3. You're going 9 to the left. 3/4 of that would be going 6.75 to the left. So that's why you're multiplying by the ratio. So this is the X. We're going to do the same thing for the Y. So the first Y value is -5. I'm adding the ratio as a fraction, which is 3/4. I'm doing X2 or Y2, sorry, Y2 minus Y1. So 4 minus -5. If you are subtracting a negative, it's going to add. Your calculator knows to do that too. If you do 4 minus 5, 5 has to be negative. That makes +9 because it's really 4 plus 5. So I'm doing -5 plus 3/4 times 9. So I'm going to do 3 divided by 4 to represent that fraction times 9, 6.75. So I'm doing -5 plus 6.75. So I'm going to add -5. So I get 1.75. So my partition point ends up at -0.75, comma 1.75. That is 3/4 of the way. Okay, next one. Find the coordinates of point Q that are 2/3 of the way along the directed line segment. So I'm gonna do X sub 1, Y sub 1, X sub 2, Y sub 2. So I'm gonna do X first. I'm starting at -7. I'm adding my ratio as a fraction. It's already 2/3. I'm gonna keep it as 2/3. And then I'm taking the further X, 2, and I'm subtracting -7. So 2 minus -7. You still have a double negative. It's subtracting a negative. So this is really -7 plus 2/3, and then 2 plus 7. 2 plus 7 is 9. So I'm going to do 2/3 times 9. So 2 divided by 3 gives me this crazy decimal. If I keep that in my decimal, it's more like keep that as the whole thing. It's more exact. If you round, it's going to be slightly off. But I will, on the test, I'll accept a range of possible answers if you round to 0.7. So I'm going to use my entire decimal, 2 divided by 3, and I'm just going to press times 9. That gives me 6 as a whole number. So -7 plus 6 is -1. So that's X. Once again, if you got a decimal because you rounded your 0.6 repeating to 0.7, it's fine. It's slightly off, but it's okay. We're going to do the same thing for Y. So I'm going to take my Y value, -2. I'm adding 2/3 of the entire length, 4 minus -2. I'm subtracting a negative, so I'm really adding them. So -2 plus 2/3, 4 plus 2. 4 plus 2 is 6. So -2 plus 2/3 times 6. Once again, I have this fraction, 2/3. I'm going to change it to a decimal, 2 divided by 3. If you round to 0.7, that is okay. Since I'm using a calculator anyways, I'm just going to keep that in my calculator. I'm not going to press times 6. It technically makes it more exact. So that makes 4. So -2 plus 4 is 2. So my coordinate point is at -1, 2. Last problem. I am partitioning. It says find the coordinates of point P that lie on line segment MN that partitions in a ratio of 4 to 6. So you have to change this to a fraction. This is 4 pieces to 6 pieces. So this changes to 4 out of total of 10 pieces because you are adding them together to make your denominator. You could reduce your fraction. Most of you are probably not doing that though. So I'm going to just use it like this to solve this problem. But you could reduce it and get the same exact answer from M to N. So I'm going to call this X sub 1, Y sub 1, X sub 2, Y sub 2. So I'm going to do X's first. -5. I'm adding my ratio, which is 4/10. And I'm multiplying by the difference. -5 minus X sub 1, which is -5. I'm subtracting a negative. When you're subtracting a negative, it's going to make a plus sign. So I have -5 plus 4/10. And then -5 plus 5. Because minusing a negative makes addition. This makes 0. -5 plus 5 is 0. So I really have -5 plus 4/10 times 0. 4/10 times 0 is just 0. So this is -5 plus 0. -5 plus 0 is -5. So that is X. I showed every single step. You do not need to show every single step if you can condense steps. I'm going to do my Y's. Y sub 1 is -2. I'm adding my ratio, which is 4/10. And then I'm multiplying by Y2 minus Y1. We are still using that same formula from up here. Where is it? Oh, where's my formula? Oh, it's right here. This is my formula. We're still using the same formula for these 3 problems. So I have Y1 plus my ratio as a fraction, and then I'm doing Y2, which is 8 minus -2. 8 minus -2. If you are subtracting a negative, you're going to add it. So -2 plus 4/10. So you have 8 plus 2. 8 plus 2 is 10. -2 plus 4/10 times 10. It's going to look a little crazy, but I'm going to take 4, divide by 10, and I'm multiplying by 10. It's a contradiction because they technically cancel. 4 divided by 10 is 0.4. I'm taking 0.4 and I'm multiplying by 10. You get 4 because technically they cancel out. So you have -2 plus 4, which is 2. So the place where it partitions at 4/10 of the way is -5, 2. I hope this helps, and I hope you stay safe during the hurricane. review your math. You have a math test soon.